Hello, DeWolf Seniors, it's me, Mr. Cheney, with another brilliant tutorial. Today we're going to go over the measuring energy in food simulation for those of you who may not have been here, for those of you who need to redo it for a better grade. We're just going to dive right into that project right now. So we're going to go into Google Classroom. The one we're talking about is this right here, measuring energy in food, the Savas simulation. So basically we were just taking data from that simulation. What you're filling out is this data sheet right here. Sheets, Google Sheets. So all of these will be filled out during the simulation. They used 4 different food samples. How do we get to the Savas simulation? Well, we go to Clever, go to My Page, Cheney's page, and we go to Savas Easy Bridge. Or you might have Savas as one of your favorites as well. So we're going to open that up. We're going to open up our textbook. And I believe it's going to be in the energy transfer and conservation. Stations of energy, I believe. Here it is. So it's called Virtual Lab Measuring Energy in Food. So let's get into it. So basically we're seeing how much thermal energy, chemical energy is in food and how much it's able to raise the temperature of water in this fancy machine called a calorimeter. So all foods have stored chemical energy in the form of fats, carbohydrates, and protein. You can estimate this chemical energy by measuring the temperature change of a water sample when a known mass particular food is burned. So that's what we're doing. Is the amount of energy stored in each type of food the same? Definitely not. We know from fats, carbohydrates, and proteins, and diets, and all that good stuff, that's not true. So how can we measure the energy of food? The specific heat of a substance is the amount of heat it takes to raise the temperature of 1 gram of the substance 1 degree Celsius. The specific heat of liquid water is 4.18 joules. The useful unit of energy is the calorie. 1 calorie is equal to 4.18 joules. So knowing that, 1 calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. So we're going to use the instruments in this lab. It's obviously a virtual lab to measure the energy of different food samples. So we'll go to the next. And here is our virtual lab right here. Our starting temperature of the water is 23 degrees Celsius. So we can go to our Excel sheet, and that's going to be the same for all of these samples. So we can put 23 for each one of these, the initial temperature of the water. And then the final temperature is going to be dependent on the food and how much energy was transferred from the food to the water. So we'll go back and we're going to select our first sample, which is the granola. We're going to weigh it, and we have 1.43 as the weight. So that is right here, initial mass of dish containing food sample, 1.43. So we're going to then transfer it to the calorimeter. Turn it on. It'll simulate burning the food, and the energy is transferred, and it went to the water and it raised it. So 25.43 is our new water measurement. So we go over here, 25.43 is that, and then we need a temperature difference of water. We could do that calculator, we could do it by in our head, or we can use Google Sheets to calculate it for us. So we can do the equal sign, big number minus small number. We have 2.43. Now we're going to weigh the empty dish, and then we're going to be able to know what the mass of the combusted food sample was. So we'll go back, and we've now got an empty container coming out of the machine. And it's going to make us weigh it over here. And we know that the empty dish is 0.40. Over here, 0.40, and once again we need to do some math. This minus this. In our head we know it's 1.03, but we'll let Excel or Sheets do the work. So it's big number minus a small number will give us the 1.03. So the mass of that empty dish is going to be the same every time, so we can go ahead and save some time by putting this all the way across. And now we just got to get the numbers for the rest of the samples. So I'll do one more and then I'll have you do the rest on your own in the simulation. So I'll go back over here, I'll put this back on the tray, then we're going to take pretzels. And that's 1.21. That is right here, the initial mass, 1.21. And we'll know the temperature once we throw it into the machine, so we're going to do that now. And pretzels are going into the calorimeter to be burned and for their chemical energy to be transferred to the water and raise the temperature. So we turn it on, simulate, water temperature went to 24.48. So we're going to put that in our chart, 24.48. So again, we need to calculate. Now in Sheets or Excel, we can cheat and we can click the formula from before, make sure our cursor changes to the plus sign, and then just bring it over like that. And we've got ourselves 1.48 temperature change, and then this same thing. We have the food mass, and we can take the formula over, and we know that the food was 0.81. Okay, so that's 2 food samples. Now this chart right here, I will show you, is in the lab notebook. So we'll go to 4 right here. It's going to calculate it for us. It's going to calculate the joules. So it needs the temperature difference of water. So I'm going to take that from the first sample, which was 2.43. And our joules are right here, so we can highlight, Control C to copy, come back to our Excel sheet, and paste right here. And this is 2.43 right here. And that's it. So that's how we do the lab. And we can take all of these final temperature differences once you have them and transfer them down here before you fill out the second table. So that gets you mostly started. You can do the rest of the simulations on your own and fill out this data. If you need help in class, obviously I will be there to support you. That's it. I will see you back in class.